Hi children, good morning. In the previous video, yesterday we discussed congruences. The definition of congruence is A is congruent to B to the mod M, meaning M divides A minus B. Okay. Congruence is a refined statement of divisibility. This was proposed by German mathematician Carl Friedrich Gauss. Okay, and basic properties of congruences also we discussed. Once again, I write those things. Here, A congruent to A to the mod M. Here, M is fixed. Here, A, B, C, and D are integers. M is fixed. Here, the second one is A is congruent to B. If A is congruent to B to the mod M, then B is also congruent to A to the mod M. Already I have proofs for this. Next, if A congruent to B to the mod M, comma, B congruent to C to the mod M, then A congruent to C to the mod M. Transitive. Next, if A congruent to B to the mod M, then A plus C is congruent to B plus C to the mod M, and AC congruent to BC to the mod M. And the next one, if A congruent to B to the mod M, comma, C congruent to D to the mod M, then A plus C congruent to B plus D to the mod M. Here AC congruent to BD to the mod M. Okay, this I explained. This one also we can prove. So here the last one, important one. I'll write here. If A congruent to B to the mod M, then A power K congruent to B power K to the mod M for the fixed value of M. These 6 properties we discussed yesterday. Okay, next. Problems based on these properties. In this class, we have to discuss problems based on these congruences. I will use some examples afterwards problems. For example, 8 congruent to 3 to the mod 5. Okay, if 8 divided by 5, then you will get 3 as the remainder. If you apply square on both sides, 8 square congruent to 3 square to the mod 5. 8 square means 64 is congruent to 9. That means 4 to the mod 5. If 64 divided by 5, then you will get 4 as the remainder. 9 divided by 4 also, you will get 4 as the remainder. Okay? Here A congruent to B to the mod M means A power K is congruent to B power K to the mod M. Like this. For example, 8 plus 3, next, another property. 8 plus 3 is congruent to 3 plus 3 to the mod 5. When A is congruent to B to the mod M mean A plus C is congruent to B plus C, like this. Here 8 plus 3 11, here 6. Here 11 divided by 5, then we will remember as 1. 6 divided by 5, the mark is greater than 1 only. The next. Now, if it is multiplied by both things, in 8 into 2 is congruent to 3 into 2, the mod 5. 8 to 16 congruent to 6 congruent to 1 to the mod 5. I mean 16 divided by 5, then you will get 1 as the remainder. If 6 divided by 5 also, you will get 1 as the remainder. Okay, in this way we can prove the reference statement of congruences. Okay, next step. Important problems based on these congruences. Problems based on the congruences. Now, show that two power 20 minus 1 is divided by 2 power 20 minus 1 is divided by 41. Okay, show that 2 power 20 minus 1 is divided by 41. Okay, here first of all we need to write the powers of 2. Mean 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6. For example, 2 power 5 congruent to, so 2 power 5 equal to 32, 2 power 6 equal to 64. Here 32 is close to 41, then 64. That's why here 2 power 5 congruent to minus 9 to the mod 41. Now 2 power 5 congruent to minus 9 to the mod 41. Already I explained 4 congruent to minus 1 to the mod 5. Mean 5 divides 4 minus of minus 1. Here also 41 divides 2 power 5 mean 32. Minus of minus 9 mean plus 9. 32 plus 9 equal to 41. So we can write it like that. Now 2 power 5 whole square is congruent to minus 9 whole square to the mod 41. Okay, already we have A is congruent to B to the mod M. Then A power K is congruent to B power K to the mod M. We can write the same power, both sides. There is no change in it. Now 2 power 5 square means 10. 2 power 5 whole power 2. Means A power n whole power n means A power mn. So 5 is 10. 2 power 10 is congruent to 81. Mod 41. If 81 divided by 41, 41 to 82. Here 81 we have. So congruent to minus 1. Mean 2 power 10 congruent to minus 1 to the mod 41. Now we want 20. That's why 2 power 10 whole square is congruent to minus 1 whole square to the mod 41. Here 2 power 20 is congruent to 1 to the mod 41, which means 41 divides 2 power 20 minus 1. 41 divides 2 power 20 minus 1. We need to show that 2 power 20 minus 1 is divided by 41. Okay. Listen once. Listen once, I will explain. Here 2 power 5 means 32, 2 power 6 means 64. If you divide by 41, 32 is close to 41. That's why I took 2 power 5. 2 power 5 is congruent to minus 9 to the mod 41 means 41 divides 32 minus 1 minus 9, 41. So 41 divides 41. So next 2 power 5 whole square minus 9 whole square mean 81. If 81 divided by 41, then we will get a minus 1 because 41 divides 81 minus of minus 1, 81, 82. So that's why I took a minus 1. 2 power 10 congruent to minus 1 to the mod 41. But we require 2 power 20. That's why again squaring on both sides. 2 power 10 whole square is congruent to minus 1 whole square to the mod 41. Mean 2 power 20 congruent to 1 to the mod 41 mean 41 divides 2 power 20 minus 1. That only we need to show. Okay, I got the definition of congruence. A is congruent to B to the mod M mean M divides A minus B. Likewise, 2 power 20 congruent to 1 to the mod 41 mean 41 divides 2 power 20 minus 1. Next, find the remainder when 5 power 2020 is divided by 24. Now find the remainder when 5 power 2020 is divided by 24. Here 5 power 1 mean 5 only, 5 square mean 25 is close to 24. Then we can take 5 square congruent to 1 to the mod 24. 5 square congruent to 1 to the mod 24. 5 square means 25. 25 divided by 24, then we will get 1 as the remainder. So it is easiest one. So we require here 5 power 2020 mean here 5 square whole power 1010 gives 2020 is congruent to 1 power 1010 to the mod 24. So here 5 power 2020 is congruent to 1 to the mod 24. So the required remainder is 1. The required remainder is 1. Next, find the remainder when the sum is equal to 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus and so on up to 1000 factorial is divided by 8. Now find the remainder when the sum of 1 factorial, 2 factorial, 3 factorial, 4 factorial and so on up to 1000 factorial is divided by 8. Then find the remainder. Here, since k factorial is divisible by 8 if k greater than or equal to 4. K factorial is divisible by 8 if k greater than or equal to 4. Because from 4 factorial onwards, one subject here. 4 factorial equal to 24. 4 factorial equal to 24. Now 5 factorial equal to 5 into 4 factorial means 24. From 4 factorial onwards, the remaining are multiples of 24. The same problem is given like this also. We can write the remainder. Here 1 factor, 2 factor, 3 factor, 4 factor, and so on 1000 factorial is divided by 24. Then what is the remainder? They ask to be same process, but the remainder is different. Here 24, 4 factorial onwards divisible by 8. Means remainder will get 0. We need to find the sum of 1 factorial, 2 factorial, 3 factorial enough. So here S equal to 1 factorial means 1, 2 factorial means 2, 3 factorial means 6, plus and so on multiple of 8. From 4 factorial onwards, it is divisible by 24, means it is also divisible by 8. So no need here. So here S equal to 9 plus 8 multiple. So here S congruent to 9 congruent to 1 to the mod 8. So the remainder is 1. The required remainder is 1 because in the given problem 4 factorial onwards it is divisible by 8. From the remaining we need to find the remainder. So here 1 factorial, 2 factorial, 3 factorial sum we require. So 1 factorial 1, 2 factorial 2 means 3 factorial 6. The sum is 9. If 9 is divided by 8, the remainder is 1. So the required remainder is 1 only. The required remainder is 1 only. Okay, next. Observe. Find the remainder when the sum 1 power 5 plus 2 power 5 plus 3 power 5 plus and so on plus 100 power 5 is divided by 4. Is divided by 4. We need to find the remainder. 1 power 5, 2 power 5, 3 power 5, 4 power 5 and so on 5 power 5 is divided by 4. Then what is the remainder they are asking? First of all, 1 power 5 is congruent to 1 to the mod 4. Divided by 4 means mod 4. Defined statement of divisibility. A congruent to A to the mod m. Already I said. So here 2 power 5 is congruent to 0 to the mod 4 because 2 power 5 is divided by 4. 2 power 5 is divided by 4. Next. Now 3 power 5 is congruent to 3 power 5 means 243. Okay. If it is divided by 4, is the remainder. That's 3, we can write it as minus 1 to the mod 4 because 3 is congruent to minus 1 to the mod 4. In 4 divides 3 minus 1 plus 1. Next. 4 power 5 is congruent to 0 to the mod 4. Next, 5. 5 congruent to 1 to the mod 4 we know, rising power both sides. Here 1 power 5 in 1 only, so 1. Next, 6 power 5 is congruent to 0 to the mod 4. 6 power 5 में 2 power 5, 3 power 5. 2 power 5 divisible by 0, multiple also divisible by 4 only. So here, next is 7 power 5. Actually 7 congruent to minus 1 to the mod 4. When 4 divides 7 minus 1 plus 1. So 8. So rising power both sides. Here 7 power 5 minus 1 power 5 is minus 1 only. That's right. First one. 8 power 5 is congruent to 0 to the mod 4. Now observe the pattern. I won't write till 100. I'll write till 10 only. It will repeat. Okay. 11 means like 1, 12 means like 2, like that only it will repeat. So don't bother about that. Here 9 congruent to 1 to the mod 4. Power 5 on both sides, then we will get the 1 only. Next, 10 congruent to 5 to the mod 4. So 10 power 5 congruent to 0 to the mod 4. In this way, our expansion follows. So clearly, if you observe, here for every alternative means even powers, you will get a 0. Out of 100 numbers, you will get a 0 50 times. Okay. By observing the given pattern, we can conclude that for every even number, you will get 0 as a matter and divided by 4. Even power. So, out of 100, for 50 numbers, you will get 0. For 2, 4, 6, 8, and 10, 12, 14, like that, you will get 0. For the remaining, the pattern is 1 and minus 1. So, here 1 power 5 plus 2 power 5 plus 3 power 5 plus and so on plus 100 power 5 is congruent to 0 mod 4 50 times plus 1 mod 4 25 times minus 1 mod 4 25 times. For every alternate even digit you will get 0. That's why 50 times you will get 0. 25 times 1. And the remaining 25 times minus 1. So here I will write here 25 times. Here 25 times. Here 50 times. So 50 times of 0, 0. 25 times of 1, 1. 25 times of minus 1 to the mod 4. So here the required answer of course 0 to the mod 4. So here the required remainder is 0. Required remainder is 0. Here they asked 1 power 5, 2 power 5, 3 power 5, and so on 100 power 5 is divided by 4, then find the remainder. So here 1 power 5 in 1 only, A is congruent to A to the mod M, like that. So 2 power 5, 6 power 5, 4 power 5, for even numbers you will get 0 as the remainder when divided by 4. Next, for odd two-way pattern, for 3 you will get a minus 1, for 7 you will get minus 1, for 11 also you will get minus 1. Okay, for 1, for 5, for 9 you will get 1 as the remainder, because 1 divided by 4 means 1 only remainder. 5 divided by 4 means 1 is the remainder. 9 divided by 4 means 4 2 8 means 1 is the remainder. Next, 13 divided by 4 means 1 is the remainder. Like that, you will get 25 minus 1s, 25 1s, and 50 0 as the remainders. We need the sum of all these, that is 0. That is 0. Don't confuse. Don't confuse. Next, find the remainder when the sum 3 power 12 plus 5 power 12 is divided by 13. Is divided by 13. Here 3 power 1 equal to 3, 3 square equal to 9, 3 cube equal to 27. 13 divided by 27 you get 1 as the remainder. So here 3 cube 27 is congruent to 1 to the mod 13, because 27 divided by 13 will be 1 as the remainder. That's why. Mean 3 cube congruent to 1 to the mod 13. Required one 12. Mean 3 cube whole power 4 is congruent to 1 power 4 to the mod 13. So 3 power 12 is congruent to 1 to the mod 13. This is first one. Next. Next, 5 power 12. So 5 square means 25. Divided by 30 minus 1 as the remainder. So here 5 square is congruent to 25 means minus 1 to the mod 30. So 13 divides 25 minus 1 minus 1 plus 1, 26. So here 5 square is congruent to minus 1 to the mod 13. So here 5 square power 6 is congruent to minus 1 whole power 6 to the mod 13. So here 5 power 12 is congruent to 1 to the mod 13. So 3 power 12 plus 5 power 12 is congruent to 1 plus 1 to the mod 13. A congruent to B to the mod M, C congruent to D to the mod M mean A plus C, B plus D we can write. So here therefore 3 power 12 plus 5 power 12 is congruent to 2 to the mod 13. The required remainder is 2. The required remainder is 2. Important one. Okay. Find the remainder when 3 power 12 plus 5 power 12 is divided by 13. Here in 3 cube close to 13 multiple. 5 square close to 13 multiple. That's why 3 cube in 27 congruent to 1 to the mod 13. So 3 power 12 congruent to 1 mod 13. That is 1. 5 square in 25 congruent to minus 1 to the mod 13. So here 5 square congruent to minus 1, 5 power 12 congruent to 1 to the mod 13. We require 3 power 12 plus 5 power 12. That's why the remainder is 1 plus 1, 2. When it is divided by 13, the remainder is 2. Next, the last one. Find the remainder when the sum to power 100 plus 3 power 100 plus 4 power 100 plus 5 power 100 is divided by 7. Tomorrow we will discuss the remaining problems. This is the last one in today's class. Here 2 power 100, 4 parts to you. First of all, 2 power 100. For getting 2 power 100, here 2 cube equal to 8, close to 7. That's why you can take 2 cube congruent to 1 to the mod 7. 2 cube means 8 divided by 7, then you get 1 as the line. So here 2 cube whole power 33 is congruent to 1 power 33 to the mod 7. In 2 power 99 congruent to 1 to the mod 7. We require 2 power 100. That's why 2 power 99 into 2 is congruent to 1 into 2 to the mod 7. Here 2 power 100 congruent to 2 to the mod 7. Next, for 3 square means 9. I'll let you. 3 square 9 divided by 7, 2 you get remainder. 2 means in terms of this one you can change. But 3 cube 27, close to multiple of 7. So 3 cube is congruent to minus 1 to the mod 7. 3 cube means 27 plus 1 28 divisible by 7. So here 3 cube. Now 3 cube whole power 33 is congruent to minus 1 power 33 to the mod 7. So here 3 power 99 is congruent to minus 1 to the mod 7. Here 3 power 99 into 3 is congruent to minus 1 into 3 mod 7. So 3 power 100 is congruent to minus 1 into 3 minus 3. Minus 3 is nothing but 4 to the mod 7. Okay. Here 4 congruent to minus 3 to mod 7 means 7 divides 4 minus 1 minus 1 plus 3. So 4 is equal to minus 3. Like that we can write. Okay, 2 things we completed. First one 2 power 100, next 3 power 100. If 2 power 100 means 2 is the remainder, 3 power 100 means 4 is the remainder. So we will write here 2 power 100 congruent to 2 to the mod 7. Here 3 power 100 congruent to 4 to the mod 7. Okay, once observe these two. I will rub and I will continue. Okay, here 2 cube 8 close to 7. That's the 2 cube congruent to 1. A is congruent to B to the mod A power k congruent to B power k. That's why we can raise power source. Here 3 power 33 means 99. 1 power 33 means 1. So here 2 power 99 we require 2 power 100. That's why multiply 2 both sides. So here 2 power 100 congruent to 2 to the cube. With 27 close to 7. That's why power 99 mean minus 1 power 3 mean 33 mean minus 1. Minus 1 or odd. So here we require 100. That's why 3 power 99 into 3. So minus 1 into 3. Minus 3. Minus 3 is nothing but 4 in terms of positive force. Next. For the 4. Now 4 square 16. 4 cube 64. 64 means 9 7 63. So we can write that 4 cube is congruent to 1 to the mod 7. So here 4 cube whole power 33 congruent to 1 power 33 to the mod 7. Here 4 power 99 is congruent to 1 to the mod 7. So here 4 power 99 is congruent to 1 into 4 here to the mod 7. So here 4 power 100 is congruent to 4 to the mod 7 multiplied by 4 both sides. 4 power 99 into 4 means 4 power 100. 1 into 4 means 4. Next. For the 5. Here 5 square 25, 5 cube 125. So close to 7 multiple. That is 5 cube congruent to minus 1 to the mod 7. 125 plus 1, 126. 126 is a multiple of 7. That's what we can use. So here 5 cube is congruent to minus 1 to the mod 7. Here 5 cube means 125. Okay, 5 cube whole power 33 is congruent to minus 1 power 33 to the mod 7. So here 5 power 99 is congruent to minus 1 to the mod 7. So 5 power 99 into 5 is congruent to minus 1 into 5 to the mod 7. So here 5 power 100 is congruent to minus 5 into 2 to the mod 7. So here 2 power 100 plus 3 power 100 plus 4 power 100 plus 5 power 100 is congruent to 2 plus 4 plus 4 plus 2 to the mod 7. So here I can 2 plus 4 6, 6 plus 6 12. 12 to the mod 7. So the required remainder x equal to here 12 divided by 7 means 5. So the required remainder is 5. The required remainder is 5. Now most important one. Most important one. 2 power 100, 3 power 100, 4 power 100, 5 power 100. 2 cube, 3 cube, 4 cube, 5 cube. 2 cube divided by 7, 1 is the remainder. 3 cube divided by 7, minus 1 is the remainder. 4 cube divided by 7, 1 is the remainder. 63, here 64 we have. 5 cube means 125, plus 1 means 126, that's why minus 1 is the remainder. So in this way, we can add the given things, you can get the remainder, required remainder. When 2 power 100, 3 power 100, 4 power 100, 5 power 100 is divided by 7, then we get the remainder as 2, 4, 4, 2. The sum is 12. 12 divided by 7 means 5 is the final remainder for this one. Okay, tomorrow we will discuss the different problems based on these congruences. Only 2, 3 left. For the completion of 2, 3 problems, I will explain Euler's-Gaussian function. Euler's-Gaussian function. For the next video, this congruences will complete. Then we will continue. Have a nice day.